Welcome to OMRON here at SMT.AI. I'm joined by Brad Ward, who's the engineering manager here in the US. Nice to see you, Brad.
Oh, thank you. We're glad to be here.
Okay. So, exciting news here because we've actually got a brand new product you're launching at the show, which is not for the typical assembly line, but really more for things like box build and other areas, because it measures other products like LEDs and different things. So explain a little bit about the machine and how it works.
So yeah, we're excited to introduce this new platform at SMT.AI this year. It's what we call AVI, so anybody who's not really familiar with that term AVI yet, it stands for Automated Visual Inspection. And really, it's very similar in concept to AOI, but like you described, really the end is that it's targeting sort of a non-traditional type inspection approaches, things like that part manufacturing, final assembly, sub-assembly processes. So the applications that we'd be targeting for those would be things like point-to-point inspection for an LED board. A good example of that would be, obviously we do a lot of LED inspection in AOI today, but typically we'd be looking at part shift on those LEDs maybe. So an LED to the left might shift a little bit to the right, but still within spec, and an LED on the right might shift a little bit towards neighbors on the left, but still within spec, but individually they're okay, but now suddenly they're a little bit too close to each other. Right. AOI can do that, but AVI is really designed to target that application a little more specifically and provide a more reliable, highly accurate type inspection approach to that.
It's measuring the pitch basically, but I mean, what sort of accuracy can it go down to?
This system can be equipped with a 6 micron per pixel resolution, which allows it to achieve an accuracy and repeatability of plus or minus 8 microns at 3 sigma, which for this application, for point-to-point measurement, is very good.
Right. So, okay, LEDs is an obvious one. What other types of applications would you see this fitting?
So another good type of dimensional application would be, let's say an example would be an automotive fuse board. These fuse boards have hundreds of these little prongs inserted into the boards. One thing we can do is measure the distance between those two prongs, because if it's too tight, then the fuses won't seat properly. If it's too loose, they might come loose later or provide a poor connectivity. So we can introduce that, that type of finite, highly accurate type of inspection. We can also do, we can also do just general purpose vision inspection, looking for things like cracks, blemishes, presence, absence, anything like that, really any sort of abnormality.
Can you look at the dimensional information on the box build, the packaging itself, if it's fitting correctly and that type of thing?
Pretty much any sort of dimensional inspection would be fair game, so we can certainly do X, Y dimensions of components or pads. We can even do trace inspection, looking for length and shape and breakage, which is of significant interest to, let's say, RF design.
Now, I think as the box build component of manufacturing automates more and more, this type of thing is going to become increasingly important. And of course, you're going to be able to extract the data off for traceability and quality control.
Yeah, absolutely. Data is important, traceability is important, and really just providing an inspection solution for these type of applications is brand new territory for everybody.
Yeah. Well, very exciting stuff. The machine is called the AVI, the VT-M12. So that's the new machine there from OMRON. Thank you very much for joining us, Brad.
Oh, thank you.